Space weather is increasing, and it turns out that we're at the beginning of a new solar activity cycle, and it begs, I guess, begs the question with many users is, okay, is this just an academic kind of a curiosity, a gee whiz kind of thing, or will these solar eruptions have some impact on systems on which I depend? And for aviators, for example, like navigation systems or communication systems would be the prime areas of interest. So what I'm here to do is maybe talk a little bit about this increasing time of space weather and the potential impacts that might have on systems on which people depend. Space weather is a hard one to describe quickly, and I think probably the best way to do it is to begin at the sun, because that's where the activity that causes space weather really starts. And it's due to the fact that the sun has strong magnetic fields, and these magnetic fields intensify and they become turbulent, and at some point they want to release extra energy. There are these episodes of eruptions that begin with these magnetic fields releasing energy, causing streams of charged particles and even clouds of charged particles to propagate out from the sun. Sometimes the Earth gets in the way. The sun doesn't care much about us from that point of view, so we go about our business, and sometimes those coronal mass ejections, as they're called, go by the Earth. They disturb the Earth's magnetic field, and that ripples down lower in the atmosphere to places that then are where navigation systems live and work, and communication systems and other things. So space weather really is a constant thing, because there are always charged particles and magnetic fields streaming away from the sun. But from time to time those events become more exaggerated and more intensified, and those are the times that we try to predict in advance, of course, from the Space Weather Prediction Center, and give people a forewarning of what's coming. Geomagnetic storms are the consequence of these episodic eruptions at the sun. And essentially, it's this extra energy that comes off in the form of magnetic field and charged particles that blows by the Earth and intensifies the input to the Earth's magnetic field. And our magnetic field then is left with a problem. It's got all of this extra energy to account for. And it goes about internal processes where it tries to digest what part of that energy it can, and then to get back to some sort of state of normalcy. But the downside of geomagnetic storms is they do have ill effects on certain systems that we depend. When the sun erupts and causes space weather to worsen here, on the one hand, some of the events will last only a few minutes, and those would be the radio blackouts that are associated with solar flares. On the other hand, and we've just seen a recent spate of this, some of the events might last for days. Typical solar cycles last about 11 years. Right now, we're at the time when those magnetic fields are intensifying and becoming more commonplace, so the potential for eruptions is greater now. And over the next 2 or 3 years, and the latest prediction I've seen for the current solar maximum is that it's going to occur possibly sometime late in 2013. Not to say that the strongest storms have to occur then, but rather it's the middle of the season, if you want to think of that way. But up through 2013, and probably for another 2 or 3 years out on the other side, say to 2016, so in round numbers for about the next 5 years, we can expect to see more frequent solar flares, which cause radio blackouts. We can expect to see more frequent coronal mass ejections, which cause geomagnetic storms, and more frequent flares and coronal mass ejections in tandem, which we think are the agents that cause solar radiation storms. So this is the season for more occurrences of space weather. But I think the people in general aviation might want to have situational awareness to be able to know, for example, as activity is accelerating and becoming heightened over the next few years, when these conditions are occurring, so they can have maybe a backup plan or a plan B. I mean, I'm sure people always have those anyway, but they can have it, a little bit fresher in their own minds should they find that they can't communicate at an important point in their flight, or their navigation looks a little funny at times and they're not quite happy with what they're seeing, at least they can have some, planning to prepare them for, some alternative. There are really two geographical markers to keep in mind in terms of space weather. One is that because space weather is so influenced by the configuration of the Earth's magnetic field and the fact that the magnetic field converges at the poles, it is usually the case that space weather is more severe. The impacts are more acute at the very high latitude regions. And the second, I guess, geographic marker is on the day side of the Earth, when there is a solar flare causing a radio blackout, it's local noontime. It's near when the sun is directly overhead that we'll feel the brunt of the impacts. Now there's a little more sort of higher order impacts that we know about down near the equator that are a little difficult to describe in a few sentences. But those are even a function of the way the Earth's magnetic field sets up. So it really is the case, I think, that for the most part it's the polar regions because of the way the magnetic field is. It's the subsolar point just because the way that the light that's emitted during the course of a solar flare travels straight out from the sun. That's where the light is the most intense. So those would be the two areas, I guess, to keep in mind. So for the pilot or the aviator who doesn't fly at very high altitudes or at high latitudes, a solar radiation storm probably is of little consequence. But if you go further away from the Earth, or you go to the parts of the Earth that are the most exposed to these charged particles, which are at the poles, then you may have some issues, not just with the radiation that you experience yourself, but just the radiation that systems on the airplane can be experiencing, because it's known that every now and then when you have a solar radiation storm, you can affect the proper function of electronics as well. I don't think there's anything a pilot can do to mitigate the effects, but I think it's back to what we've talked about earlier, is that just to be situationally aware and think of a lot of parallels with terrestrial weather. And as you go about your business and you prepare for a flight, or you've already started your flight, just to know the conditions. If this is going to be a day where your navigation is going to be rock solid or maybe not exactly rock solid, or if your ability to communicate is going to be crystal clear or maybe less so. I think that's probably what a good plan would include, is just some contingency plan should you find that a system on which you rely is just not quite working the way that you think. I think the decision about whether to fly or to stay on the ground is really, as it should be, left up to the individual, based on all of the things we've talked about where on Earth you're flying, because the impacts are different depending on where you are, whether it's daytime or nighttime, whether the other factors, the important factors of normal weather, convective weather and such, are of a certain type, how much freedom you have with your schedule. So I wouldn't advocate that you look at our website and make a decision based solely on the space weather impacts or potential impacts, but rather I think just include it as one part of your planning mix.